Alright, number 7, given a linked list where every node represents a linked list and contains 2 pointers of its type, a next pointer to the next node, and a bottom pointer to a linked list where this node is head. So here is what we're starting off with. You can see there's a linked list here that goes from left to right, and these are the next pointers, and then at each node each node is a head within itself that points down to a linked list that is going underneath. And then this is the result that we want to end up with, where it contains everything within the structure and it's all laid out in ascending order here. And so we can see we have 5 and 5 here, and then 7, 8 from here, and then 10 is the next one that came from here, and then 19 here, then 20 here, and then 22, 22, 28, 28 here, 30, 30, 40, and 40. Oh, there should be a 35. Okay, that, and then 45, 45, and then 50. And so we're just, so we just want to take all of the notes that are contained within this entire organization of linked lists and organize it into one ascending order linked list. So the logic for the solution is we're going to be merging 2 vertical lists at a time, and then we'll be using a recursive function to take the sorted list and continue on sorting down all of the vertical lists that we have. So we have the flatten function here, and we'll have our root node starting here. And if root is equal to null or root dot right, or the right of the root is null, then we just return the root. And then we have a recursive, this is a recursive function, so we'll be continuing on down. So we have root, and we have root dot right. So we take root dot right is equal to this flatten function. So we pass root dot right becomes root, and neither root nor root dot right is null. So we continue on, and so now this is root dot right, and we call this function. So this becomes root. Again, we haven't hit null, or we don't have null to the right of it, so we have root dot right. And then we call this and so now we have root. In this case, root dot right is equal to null, so we return root. And so so since root was passed through this function, we'll be taking root back to this list, and so this list is root, and this is root right, and we merge these 2 lists. Root equals merge of root dot right. So our merge function here will have a node A and a node B, and if either of these become null, then we just return the other lists. And then if A is less than B, then we will then the result will be A, and then we have another recursive call here, and we'll just be continuing downwards, and then vice versa if B is less than A. So we have A and we have B, and so we have A is less than B. So if A is less than B, then result is A, which is 19. And result down. So then we perform this again. And so now we're doing this merge function with A dot down and B. And so we'll be passing A through, A comes down here. Now we have A is 22 and B is 28, so A is less than B. So repeat that again, and so our result, this becomes our result. We have 22, and we'll have result down, and we'll be passing again A down and B. So now B is less than 28 is less than 50, so we come to this else, so result becomes B. And then result down. And then we'll do this merge with A and B down, B dot down. I'm gonna pass this through, this becomes B. And so 35 is less than 50, so that becomes the result. And then we just continue on. Result dot down. And this is B down. And becomes B. Then 40 is less than 50, so we pass that through. And then result down comes the merge function of B dot down. And it becomes B. And 45 is less than 50. That's our result. Result dot down equals and we'll have B dot down will now be at null, so now B is equal to null, so we just returned A. Yeah, and so then, yeah, and then our result, all right, is null. And we return results. So root becomes, so we see root is the merge of this function. All right, so this is our root equals to the merge function, the merge list that we just sorted. And because we are doing this recursively, we're gonna go backwards now, and so this becomes our root, and this becomes our root dot right. And so then root equals merge of root and root dot right. So all right, and then this is the result of these two linked lists merged, and so then this root will now become this. So here's the resulting root merge of the next iteration of the merge list, and again we'll call back to this being the root dot right, and then we'll perform the merge function on these two. Alright, and so then, and now this is the final single merged list that we have. And this is a root. We have null to the right, and so now root is not equal to null, but our root dot right is not equal to null, so we return our root, which is what the final merged single linked list that we have, and we can see here 5, 7, 8, 10, 19, 20, 28, 30, 35, 40, 45, 50. We have everything here in ascending order. And then the time complexity for this is O of n, and the space complexity is O of 1.